Hello, folks. I wanted to talk about graphing this equation in polar form, r equals 2 plus 2 cosine theta. So there are two kind of ways to do it. One of which is to graph it in, treat it like a rectangular equation, graph it in rectangular form. So like y equals 2 plus 2 cosine theta. And hopefully we can do this without having to draw a t-chart or get a calculator, right? So we've gone through in a previous chapter analyzing and graphing a trig function. So the vertical shift of this here is up to the period is 2 pi divided by k, where k is the number in front of the theta input, which is 1, so this is 2 pi. The horizontal shift, the phase shift, is b, something added or subtracted inside of the input, which there's nothing being added or subtracted to the theta, so it's 0. The amplitude is the absolute value of the number in front of the, multiplying in front of the trig function, so 2. So the regular cosine function looks like this and bottoms out at 1 and negative 1, right? So it bottoms out at pi, and it gets back and starts repeating itself after 2 pi. So this graph in rectangular form is just going to be that moved up 2. So its center line is going to kind of be here at 2, and at pi it'll bottom out. And go back up at 2 pi. So the intercepts here are going to, the intercepts of the center line are going to be at pi over 2 and 3 pi over 2. So we could use this graph to help us draw this in polar form. The other way that the book talks about doing this is kind of writing out a t-chart, which is equivalent to reading off information off the graph. So if I make a t-chart for this, that's a chart with the input and output. So theta is the input in one column and outputs in the other column. So let's just go ahead and put some values in here. So when we were doing our graphing chapter, we talked about taking the period of our function and multiplying it by quarters. So we do the same sort of thing here. So 1/4 times 2 pi, or in other words, pi over 2, 2/4 times 2 pi, or pi, 3/4 times 2 pi. Um, 3 pi over 2, 4/4 times 2 pi, or 8 pi over 4, 2 pi. And what I would recommend doing is some of the examples and problems that are worked in the book, for example, require more than one period to graph. Is I would recommend keep going through 2 pi. 2 periods. So through continue on here through 5/4 times 2 pi, and so on and so on. However, for this particular example, that's not necessary, and so just to keep it short, I'm going to stop here. And then, so we take these and input them as values into our function and get some output values. So 2 plus 2 cosine, 2 plus 2 times cosine of 0. So cosine of 0 is 1. 2 plus 2 cosine pi over 2, that's 2 plus 2 times 0, or 2. Note, these are corresponding to points on our graph, right? That's why I said these are actually kind of equivalent ways. This is useful information. These points, this graph are useful information to enable us to draw this in polar form. 2 plus 2 cosine pi, 2 plus 2 times -1. And again, these keep corresponding to points on our graph here. Okay. So now if we want to take this information and draw this in polar form, so in polar form, as opposed to a grid, we have kind of concentric circles going away from the origin, representing different distances, different r values, distances from 0. So let's start at angle 0, which lies from standard position along here. At angle 0, and we could read off the coordinates of a point to plop on this by either looking at this point or getting the coordinates out of here. At angle 0, there's a point with an r value of 4. So that's right here. At pi over 2, which is straight up and down, there is a point with an r value of 2 right here. At pi, which is right here, there's a point that is 0 away from the origin. At 3 pi over 2 downwards, there's a point that is 2 away. And then at 2 pi, so back to here, there is a point that is 4 away from the origin that overlaps this point that we already have. Now we need to play connect the dots. So the first point we drew was here, the second one was here, so let's connect those. So we could kind of ascertain how the line or curve connecting these is going to go by looking. This graph tells us what the r value is doing from 0 to pi over 2. It's going down. In other words, the curve that connects this point to this point is getting closer and closer to the origin. Well, if we just kind of draw a nice little curve connecting them, this area over here is closer than here. So that jives with the information we have. And then as we move from pi over 2 to pi, the r value decreases to 0. In other words, this is going to curve into the origin. And then as we go from angle pi to 3 pi over 2, so as we rotate from here to here, we're going to leave, the r value is going to increase from 0, r value of 0, to an r value of 2. So we're going to spin around to there. And then as we go from pi over 2 to 2 pi, the r value is again going to go increase. So it's going to get further away from the origin and connect up our last 2 points that we plotted. And this is the equation of a heart. So I hope that this helps you. And this is an approximate amount of the amount of work that I'm looking for you need to show on tests. As always, my door is always open. Feel free to ask questions. And I hope you guys have a good afternoon.